In these two examples, we are going to be doing the antiderivative, but we're going to be able to go a little bit further than what we've done on these other ones. We're going to do the antiderivative, and they give us enough information to figure out what this constant is. So we have a derivative, but we also have a coordinate. And that's where we're going to be able to plug in the x and the y into an antiderivative, and that's the piece that we'll be able to figure out from that. Okay, so we are going to do our antiderivative to the integral of 7x to the 6th minus 4x cubed plus 12. And we're going to do the antiderivative of it. We'll do the integral. So if this was our original function f prime, we're going to do the antiderivative and create original function. And so if we follow the steps to it, we would add a power, divide by that power, minus 4x to the 4th. We add a power, divide by that power, and then plus 12x. But then we've always added this plus c, said unless we had more information. We do have more information. We have an x value that we can plug in, and then we have a y value that we can set it equal to. So let's do one more little piece of cleanup on this. So this would become an x to the 7th minus x to the 4th plus 12x plus c. All right, so if we were to graph this, we're looking for a very particular c value that's going to have this coordinate right here, this 124 coordinate. So we can go ahead and set this equation equal to 24 while we're plugging in the 1. So then the only thing missing is going to be this c. So we could graph this and we could trial and error this and put a 1 here and a 2 here and a 3 here, and on and on and on and on. And at some point, if we were to throw this into Desmos, we would keep on shifting, and at some point it's going to cross that. But rather than doing this trial and error, let's just go ahead and take advantage of the coordinate they give us. Let's find a better way. So this is going to be 24. It's going to equal 1 minus 1 plus 12 plus c. So 24 equals, that goes away, 12 plus c, subtract our 12. C is going to be 12. So our function is, our final function is x to the 7th minus x to the 4th plus 12x plus that c value of 12. So it would do two things for us. If we were to graph this, it would pass through that point, and then the derivative of it would also equal this. Because when you do the derivative of it, that constant is just going to fall off anyway. So that 12x is creating that 12. Right, so let's do the same thing with the trig one. Right, so if we do the antiderivative of this, we're going to be doing the antiderivative of 1 plus 6 sine x. Okay, so the integral. So the antiderivative, the integral of 1 is x sine, right? So the derivative of, let me kind of go through the path here. So the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is sine. So we're sitting here and we're moving backwards. So when we do the antiderivative of sine, we're going to get negative cosine. So that's going to be plus 6 times negative cosine x, and then plus c. So that is our original function. Okay, so if we clean that up just a smidge, we'll have x minus 6 cosine x plus c. So back to this type of problem. We're here, but we have enough information. They tell us that if you were to plug in pi over 3, we get a negative 3 out of it. So then let's do that. We're going to plug in pi over 3, and we're going to set it equal to that negative 3. So negative 3 equals pi over 3 minus 6 times cosine of pi over 3 plus c. And then we can solve for c. So cosine of pi over 3 is cosine of 60. Well, I have that memorized. But I can draw my 30, 60, 90 triangle, which is a 1 to root 3 ratios. And so cosine of 60 is 1 over 2. So negative 3 equals pi over 3 minus 6 times 1/2 plus c, right? Because it's adjacent over hypotenuse. All right, so let's figure out the math on this. We have a negative 3 equals pi over 3. And then this is going to be a minus 3 plus c. You can add 3 over. Wonderful. That goes away. So we're looking at 0 equals pi over 3 plus that c value. We'll subtract the pi over 3 over. So c is negative pi over 3. So our original function, g of x, would be right here, x minus 6 cosine x plus minus the pi over 3 for our constant. So we would do two things again. If we were to do the derivative of it, we would get this, because that pi over 3 would fall off. So that would get you the 1. Derivative of cosine is a negative sign, changing this to a positive 6 sign. And then not only that, but if you were to plug in pi over 3, it would be equal to negative 3. And so that is our original function.